the pH meter calibration. So first, you want to click on File and create a new file for your calibration. Then you want to take the pH meter, you want to rinse it off with the washer. Then once that's done, you can then put it in the respective buffers. We're going to start on a buffer 4 and calibrate the pH to that said buffer. You have to wait till the numbers are consistent once the pH meter is in that buffer. So once you get a consistent number, you want to press keep. Then you want to take your pH meter out of the buffer 4, and then you want to wash it with the distilled water. And then before you put your pH meter in the buffer 7, you want to wash it off with the washer again, and then put it in the buffer 7, wait for a consistent number, and then press keep again. Once that's done, you want to hit the calibrate button, and now you're ready to measure your solutions. When it comes to properly measuring your solutions, you want to make sure that the pH that you get on your meter is consistent. So you should wait a while, make sure the number stays consistent for a short period of time, and then write that number down in your notebook. Also, you should always put things back the way you found them. So you want to take your pH meter, take the solution that is held in when you found it, twist the cap on while holding it inside the solution. Then once that's done, you want to curl up the wires and tie it with a zip tie while also unplugging it from the LabQuest, and then putting the LabQuest back on the charger and the pH meter in the pH meter box. Buffer solution. A buffer solution is an aqueous solution that is made up of a weak acid and its respective conjugate base. The pH of the solution has a minor change when a strong acid or base is added into the buffer solution. The reason for this is that since both acids and bases are weak, they will give up or react to make more H3O strong base to weak acid, or react to make more H3 plus strong acid to weak base, which is only slightly changes the pH. Weak acids versus strong acids. Strong acids completely dissociate to form ions in the solution. However, weak acids will only partially dissociate. This means that when it comes to weak acids, the equation is reversible. Since they partially dissociate, the chemical equation will go back and forth until the concentrations are equal, which is then when it reaches equilibrium. However, when it comes to strong acids, equilibrium is possible mathematically, but in the real world can only happen in extreme conditions since they completely dissociate.